So this is just a review video to help you as you prepare to do the extra credit assignment. So I encourage you to attempt this extra credit assignment on your own and check your work with the video. Then when you're done, go to the quiz, and just keep in mind the values for the quiz will be different and they might be stated within the quiz. So open the file and read the quiz questions carefully. Let's begin. Washington river otters have a mean of 6 and a standard deviation of 1 feet. We want to find the z-score for a river otter that is 4 feet long. So for the z-score, we take the value given minus the mean, divide that by the standard deviation, and we're going to get a z-score of negative 2.0 in this case. Now it says according to the empirical rule. Now the empirical rule was discussed back in section 7.1 of our course notes and lecture videos. So you can look there, and I've actually got a screenshot of that here so you can reference it on the screen. It says 99% of the values should lie between what lengths of the river otters. So here, when they mention empirical rule, we have to think about these three things. It says 68% is with 1 standard deviation, 95% is within 2, and 99.7 is within 3 standard deviations. So basically, we have our mean here at 6, and it said that 99.7% should be within 3 standard deviations of the mean in each direction. So you take the mean and you add 3 standard deviations to get that farthest right z-score. Our standard deviation is 1, so 1 standard deviation is 7 over. The next one is 8, and the final one is 9. And in the opposite direction, 1 standard deviation away from 6 is 5. Another one away from 6 is 4. Another one is 3. So for this problem, 99.7% of all the values should lie between 3 feet and 9 feet. And our reasoning for that is 3 standard deviations to the right of the mean and to the left of the mean. And then just keep in mind the problem would be slightly different if it was 68 versus 95%. If it was 68%, then you would only go between 5 and 7 because that's 1 standard deviation to each side. If it's 95%, then you go 2 standard deviations to each side, and that'd be 4 and 8. So that's the idea for B. So here it says find the probability of selecting a river otter that's less than 4 feet, what we had here in part A. So I know my z-score for that is negative 2. So if I have my chart here, I'm going to draw my z-score of negative 2 here. And we know that our normal distribution table gives values to the left in the area, so we can just get the probability directly from the table. Let's bring up the table here. So let's find negative 2 on our chart. So for negative 2, we look and we see negative 2.0, and this is the 0.0 column is the first, so that would be 0.228. Let's write. So that area is 0.0228, and that's our answer. Now if we were to find the probability of getting one that was more than 7 feet, first 7's a new value, so I need to find my new z value. So 7 minus, let's recall the mean is 6, standard deviation is 1. 7 minus 6 divided by 1, that's a z-score of 1. So in this case, I would have my 7 feet, or we could keep this our z-score of 1, and I want to find what's more than that. Now we know when we look at our chart, it's going to give us everything to the left. So let's find that first, because the standard deviation chart always gives to the left. So we scroll this, and we're looking for the standard deviation of 1 on the dot. This is the 0.00 column. So 1.00 is 84.13. Let's write that down. This is 0.8413. Now keep in mind that's less than, because it's always to the left. So the total value is 1. So to find what we're actually looking for, we take 1 minus 0.8413, and we'll get this remaining value. And the remaining value is 0.1587, and that's what is for the values more than 7 feet. So next up is the river otter that is between 4 and 6.5. This doesn't always happen, but I noticed that the 4 was actually a given value earlier, so I don't have to find its z-score again. I can just say for 4 feet, recall the z-score was -2. Now 6.5 is a new value, so for 6.5 I'm going to have to find a new z-score. 6.5 minus the mean of, in this problem it was 6, minus a standard deviation of 1. That gives me a z-score of 0.5. And to find the value in between, remember to find the area in between, you always take the area that comes from the farthest right, so we'll find whatever area that is first, and then we'll subtract it from the area that comes from the farthest left. Now we want to look for a z-score of 0.5, so again 0.5 has this first column 0.000. That'll be 69.15 is the area to the left of that. So area to the left of that is 60.6915. And next we know the area to the left of the 4, I think we actually already found that, so we don't have to find it again, we can just reference it to the top. So the area to the left of the other one was 0.0228. And now to find the area between, you take the larger area and subtract it from the smaller area. We'll type that into our calculator to get our answer, and we get 0.6687 for this answer. Now for this last question, they're asking us to find the 90th percentile for the lengths of river otters. Now whenever they tell you a percentile, remember that's a different way of telling you the area to the left. So in this case, the area to the left is 90% of the whole. So we can find this in the z-chart if we turn our percent to a decimal. To turn the percent to a decimal, you move the decimal place over twice. So we're going to look on the chart to see what area to the left corresponds to 0.9. Then we can find its z-score, and we can find that length after converting the z-score. So let's first find our chart and see where do we see 0.90 in the chart as close as possible. So I'm going to look here. 0.9 is a large area, so I'm going to look definitely in the positive zone. So 0.88, 0.89, 0.895, keep going. Okay, 0.8997, that's close, 0.915. And then after that is 0.932. So here at 0.9015, we've passed the 90th percentile. So the first time we get to the 90th percentile or above is at, let's trace this back, 1.2, and then it's in the column of 0.09. So that would be 1.29. So that corresponds to a z-score of 1. And I apologize, I misspoke. The 1.29, it is when it's greater than 90, but I just made a mistake for a second. So forget that. Whenever you're trying to find it, notice here, this one is only 0.003 away, whereas this one is 0.015 away. The 0.915 is actually farther away from 0.90 than the 0.8997. This value is very close to 0.90 on the dot. This one is farther away as a distance. So we're going to go with this number. So again, I apologize for the error. But now that we've corrected it, that's going with 1.2 and a 0.08. So that's a 1.28. So that'll be a z-score of 1.28. Now, the z-score is 1.28, but the value is, to find the z-score, you take the value we're looking for minus the mean, which in our case is 6, divided by 1, and we can solve for our unknown using algebra. So multiply both sides by 1, we get a 1.28 equals our unknown minus 6, and then we're going to add 6 to both sides. Our unknown is equal to 7.28. So you would have to have that length of river otter such that 90% of all other river otter lengths are less than or equal to that. Now keep in mind, all of this was based on R6 and R1. That came from the very beginning when we were given the mean and the standard deviation. As you do this problem in the actual extra credit, the numbers will not be these numbers. So please pay attention and use the new numbers in your actual extra credit assignment. This was just for practice. So again, keep in mind the concepts that we're going over are the same, but the numbers will be different on the actual assignment. So as you do this practice, please reach out if you have any questions, and I hope you have a wonderful day. Thank you.